Last question, the prime numbers. What's a prime number? Look it up. There's a link. There's even a link. So what you see with prime numbers, it's a natural number divided by 1 or itself, right? So 2, 3, 5, 7, 11, and so on. I'm going to create a function where also the 1 is in it because it's, well, because I'm lazy, basically. And so how do we do that? Okay, I'm gonna get down in this test area. Take you have numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. There's a simple rule you can apply. Let's say we divide, symbol of dividing, oops, let's use this, by 2. What do you get? You want 1, 2, 3, but you do not want 4 anymore. You do not want 6. 8 needs to get out, 10 needs to get out, 12 needs to get out, 14 out, 16 out, 18 out, and 20 out, right? So then you divide again by 3. So that's this copied, but 9's out, 12 was out, but it was already out, 15 gets out of it. And that's like the prime numbers you have below 20, if I'm not mistaken. You can do the same with 4, but 4 is actually the same as 2, so we already did it. And then you can have 5, but in this case there is not dividable by 5 anymore. And 5 go on with 6, 7, and so on, and you will see that there's nothing actually to take out anymore. So this is a basic example what the algorithm will look like. We are not, the algorithm wouldn't be clever, so it just really needs to check to everything that it can be divided by 4 or not. We'll show how it works in a second. So I'll just stop, well, I'll just remove this again because I'm gonna get errors. Create a function, call it prime array. So I want an array with prime numbers, and I'm gonna give again an index to tell me how big, well, how many I want to check. The first thing I want to do is I'm gonna use a dummy array, an array that's gonna be to check which one I need to delete or not. So I'll gonna create something so I can scrap the functions, the numbers that are dividable, so which are not a prime number. That's the first thing I will try to do. To do that, I will fill an array. So if I just go to PHP manual, there is a function called array fill. It takes index start and then the index as the latest value and then numbers to fill in. Let's see over here. A is an array fill of 5 and 6 with banana. So it starts at 5 and it adds 6 keys with banana, right? That's basically it. So what we will need is a temporary array I will call prime, which will be an array fill. Never mind. Fill from 0. So I'll start at 0. Do I start at 0? Well, could start at, yeah, I'll start at 0. And I'm gonna say that each and every one of them, I'll start at 0. I end at the index. And I'll say that they need to be filled with false. Or false or true. No, it's going to be easier if I say true. Okay, so I'll explain right away what this will do. So I create an array, and each value is potentially a prime number. That's what this will say. So having said this, I will first of all try to like remove everything divided by 2. So I'm going to use a for. I starts at 2 because I want 2 itself to be in it. And I never need to check more than the half of the index, because if it's, for example, if it's, yeah, well, I'll explain it right away. First of all, let me just finish this. So what I'll do in this is say that prime for I multiplied with 2 is false. So what does this do? This goes to, so the first time it's going to be 2, right? So it says prime of 4 is false. Then it goes to 3 and it says prime of 6 is false. But it never needs to be bigger than 5 because, for example, I had 20, I was testing with 20 below. So if I have 10 over here, oh, divided by 2, not 5. So 20 divided by 2, that's 10. So 10 multiplied with 2 is 20. So I never need to check for a number that's bigger than half of the numbers I'm testing. Okay. So this is the first tests. The second thing to do is actually get the prime numbers themselves, because this is just a temporary array to see that a certain key is linked to false. So the next thing I'll do is go over the array again, say start with 2, and say that I is smaller than the index, because now I want to check for every key in this prime. What I'm gonna do, I'm gonna create now an output array where I'm gonna append. So if I don't put anything in there, the system will assume that you add a new element at the back. So this is an append. Append the, oh, again, too fast. Let me delete it. First I need to check if prime of I need to check if prime of I, meaning that is this still a prime number? So I said before 4 would be false, so 4 would not be a prime number, okay? So if it is not a prime, if it is a prime number, I'll just need to create an output array, out, where the key is entered. So because 4 is going to be false, 4 is not going to be in my output array, but 2 will, and so on. And let's just test it. Return out. It's always better to use small steps and then test to see what happens. Okay, mark this out. So print array with 20. So give me the 20 first prime numbers. Let's get back. There is my localhost. Okay, so what I got now is 2, 3, you see 4 is out of it, 5, 6 is out of it, 7, 8 out, 10 is out, 11 is out, and 20 is out. Okay, that seems all fine. That seems all fine. The thing is, of course, that I only took out 2, right? So the next thing to do is make sure that I take all of them out, which means that I actually need a second for. I will change this 2 to a variable called g. So I'm going to copy this, put it over here, put this one. So the prime number is going to be 1 deeper. Start with g. Again, say that g never needs to be bigger than half of the index. And then g over here. And so what we have now is that, so the first time this runs, it runs with g is equal to 2, right? And it takes out all the even numbers. The second time g will be 3, and we go back from 2 to 10, and we take out all the possible indexes again, right? So then the 9 needs to get out, and the 15 needs to go out. And then it loops over without finding any, and it will actually give me the prime number. So 2, 3, 5, 7, 11, and 19. And if I make the number bigger, say 100, ta-da, it will work. Now let's try a last test to see if I made it well enough. 19 is a prime number, right? Well, let's say 13 is a prime number. 13, does it still in the table? So I want 2, 3, 5, 7, 11, and 13. You see that in this case, 2, 3, 5, 7, 11, 13 is not in it. I missed 13. How come? So what we need to check. So what I'm gonna do now is actually show you how you could simply debug your code. So I'm gonna print here, let's say print the prime. I'm gonna use print R to have everything. The primes C. Is this actually working? So what you see is now is 0 goes to 1, 1 goes to 2, blah 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 blah, 19, 12, no 13. There's no 13 here, right? But we need key 13. So what we actually had to do is add over here +1. Test it. 13 is a prime number, so it says that 13 works. But you see that over here, I only check until I, right? So I also need to make sure that it's smaller than or equal to index. And now it's gonna have my 13 over there. But now let's see if I still, so I can remove this debug code, right? So debugging is a very useful tool for most simple codes. So you see 20 is not in it. Everything seems to work, and even in exceptional case that the number you entered is a prime number, it will be in there, right? And that's it.